All right, well, we are very excited today to welcome Dr. Christian Kammerer from our very own North Carolina Museum of Natural Sciences today to talk to us about the Permian. I don't know if any of you here today had a chance to attend the exhibit upstairs, but hopefully if we end early enough, our box office has offered, if you are here today and tell them you're with the Fossil Club, you can get the group rate for tickets. So take advantage of that if you haven't had a chance, because I think that's really nice of them to offer that to us. So without any further ado, I'm going to turn this over to Christian, who is going to talk about news from the Permo-Triassic tetrapod discoveries from around the world despite the pandemic.
Thank you very much for the introduction, Terry, and for inviting me to be here. I'm delighted to welcome you all back to the museum. I am curator of paleontology here and also the institutional liaison for the Fossil Club. So really happy to see so many fellow fossil fans in person and then also online. So, you know, as I think we all know, it's been a difficult few years professionally as well as personally. But paleontology has persevered. And today I'm going to be talking about some of the research that I've done on my own specialty, which is the Permian and Triassic periods, despite all of the sort of strictures of recent times. So for people online, I'm going to be switching my screen so that you can see the talk. So let me get that going here.
A little inception thing.
Okay, do people see that? Do we have thumbs up from the audience? All right, great. So yeah, so just get out of the way here. This works. Over here. It's working just earlier.
Yeah, let me just try this.
It's funny because we tested it before and then that would stop working. Okay. Apologies, folks. You know.
Try this one. Yeah, this one's, the batteries are good.
All right.
The lasers working. So here's this. It should be working.
Yeah, I wonder if
Do
it's.
you want me to connect your slideshow for you? I can do that.
Oh, I got
There
it.
we go.
All right, we're in business, folks. Okay, great. So yeah, talking about some news from the Permo-Triassic. So just as a brief introduction to Permian vertebrate fauna, so I'm a vertebrate paleontologist primarily. This is one of the great junctures in the history of life on Earth, because we're moving from the archaic Paleozoic fauna, so the earliest animal and plant ecosystems, into what's a much more modern world in the Mesozoic. And I know that may seem a little strange because from our Cenozoic perspective, even the Mesozoic seems very ancient. But we're looking at fundamental restructuring, not only of what types of organisms were there, like dinosaurs versus mammals, but changes in basically the entire community. So we're moving from very aquatic focused ecosystems in the Paleozoic to, at least in the terrestrial realm, much more modern ecosystems. But what we think of in faunas today, where we have a few top predators and then some smaller mid-sized predators, and then a lot of primary consumers, herbivores, and then lots of small-sized detritivores, insects, and things like that. So you don't really see that sort of pyramidal trophic structure in the Paleozoic. So the Paleozoic ends with the biggest mass extinction in Earth history, which I've marked a little explosion there, the Permian event. So this was driven by A number of factors. It was really a spectacularly bad time to be alive on planet Earth, but mostly from the Siberian traps volcanism, in which roughly a third of the land area of what is now Asia was covered in these series of basaltic provinces of supervolcanoes that were active probably for around 100,000 years. And then not only was that devastating for the animals that were living in that particular spot, of course, the longer term environmental changes driven by toxic gases in the atmosphere, changes to ocean circulation, global warming, ended up killing off roughly 80% of species on Earth. It seems to have been more intense in the ocean than on land, maybe as much as 95% of species in the ocean versus around 70% on land. But also we don't have as good of a record of the land animals than the ocean ones, so that may be an underestimate. And also this is not just killing off individual species, but entire clades, entire large groups of organisms. So many of the marine reef building creatures like rugosine corals, horn corals, and trilobites, they finally meet their end at the end of the Permian. And then new faunas starting up in the Triassic. So in terms of the terrestrial vertebrates, the typical Permian animals are these iconic taxa like Dimetrodon and its relative Adaptosaurus. So these are synapsids. These are early members of the mammal line, and they're the dominant animals basically throughout the Permian. So you start off with these pretty archaic forms that we call the pelycosaurs. So that's like Dimetrodon. And then as you move into these later Permian forms, you start getting the more advanced, more mammal-like therapsids, represented by these big Gorgonopsians, like Inostrancevia here, and then also some of the first large true reptiles, like this is a Pariasaur, Stegosaurus. So these animals are very common throughout the late Permian before they're wiped out, basically, by the end of Permian mass extinction. So our knowledge of Permian biogeography, sort of the distribution of animals across the world, it's somewhat limited. So it seems like there's a very strong latitudinal bias towards our record between the early and the late Permian. So the early Permian record is very strongly equatorial. So we think about like where Dimetrodon is found, it's mostly in the American Southwest, in places like Texas, New Mexico, but there are also records from Germany, the UK. So at the time, these were all part of this sort of central humid equatorial belt. But then in the late Permian, we actually have very few equatorial vertebrate records on land. And we're mostly getting things in these temperate zones, most famously in Southern Africa, which is an area I'll talk about more in the rest of the talk, but then also in the North China block, what is now European Russia, and some parts of Central Europe. So there's only a few exceptions to this. There's some sites actually of uncertain age, but with very interesting faunas. So, for example, there's, see here, there's a few from, just taking time to load. There's a few from Africa, from probably the late Permian, maybe the middle Permian, such as in Morocco, and let's see, just press this here. Oh no, it's really stuck. Okay, let's give it a second.
Fully frozen. Okay, here we go.
All right, we're back. So yeah, so we have the Ikakern Formation in Morocco, the Maradi Formation in Niger, and a place that I've worked in a lot, and we'll be talking about more, the Pedro de Fogo Formation in Brazil. So these are kind of the outliers that are really, expanding our understanding of what's going on in the equatorial regions later into the Permian. So in the past 20 years of working on these animals, I've had the opportunity to really look at fossils from around the world. Permian is the time of Pangea. So Permian fossils are found worldwide. The same is true of the succeeding Triassic period. So I've been able to work on fossils from every continent. Indeed, I've collected fossils on every continent but Antarctica, still trying to cross that last one off, hopefully in the future. So this is just showing you some of my history going doing field work in South Africa, in Russia, collections work in Argentina and Brazil. And this was a huge, part of my work as a scientist. As someone working on the Permian, you're part of a global community of Pangean researchers. So, especially as someone who specializes in these early synapsids, there are not many of us. So, when new ones are discovered, you might get called out, okay, they have to look at these things in Namibia or look at these things from Uruguay or what have you. This was a large part of my career. Indeed, so at the circa February of 2020, I had been called away to the Musée Naturel, the big natural history museum in Paris, which is truly one of the most spectacular museums on Earth. If you've never had the chance to go there, highly recommend it. Sort of the grand gallery of osteology alone is just, breathtaking. So many skeletons sort of packed together, including some species that you really won't see anywhere else. But I've been called over there to actually to be the external advisor for a student who was describing new Dicynodonts, this group of beaked herbivorous synapsids from Laos. The Laotian fauna is only recently, being studied to any real extent. It's been known that fossils existed there since the 1920s during the French colonial period, but only like in the past 10 years or so has there been serious work done on the Laotian Permian. So she was starting in work on that. And it seemed like things were going all well and good. But then, of course, March 2020 hits. Basically, as soon as I got back from this trip, we were told to clear out our offices and the museum went into lockdown. So my career went from basically a lot of this, globe trotting, going to museums, being out into the field, to this, hanging out in my kitchen, working on papers for really the next year or so. So what is a field scientist like myself to do in lockdown scenario? Can't just stop working, sort of throw up our hands and say, well, that's it, pandemic. So had to readjust, come up with some new priorities, figure out new ways to do our science. And for me, it was really kind of three things three approaches that I took. One is to, changing priorities. So a lot of my activities, a lot of my major research projects were predicated on going out, like doing field work, doing the basic geology, finding new fossils. That was no longer possible. So we were moving to, in the course of visiting museums, there's always you discover more than you can get down on paper. There's always interesting things like, oh, this would be good to write a paper about. But maybe, it's never the top thing on your to-do list. So you create this series of projects for the back burner. This was an excellent time actually to start clearing those off. The second one is, what can we do with the specimens that we already have? So using new approaches, modern technologies, to bring more and more data from the specimens that I already have here at the museum. And third, try to get back out into the field however we can, sort of where we can, in sort of our new world. So I'm going to be sharing the results of basically some of the papers that I've been publishing in the past few years. So starting off with some of these kind of back burner projects. These are some fairly fragmentary finds, but what I consider very lucky finds from northern Brazil, which is an incredibly hot, but truly beautiful place to work. So this is at a site that I mentioned earlier, the Pedro de Fogo Formation. This is in northeastern part of the country in the Parnaíba Basin. So I've talked about this work a little bit for the Fossil Club before. We have been going to these sites for over 10 years now, and they've proven very productive. And a lot of our previous work, the published work, has to do with the aquatic fauna. So what we do is there are these small local rock quarries that are targeting these Permian rocks for building materials by the local people. And we're basically just going through the spoil piles and looking for any evidence of bone. And sometimes we'll find sort of a chunk of it that we're able to follow into the hillside and then actually do proper excavation But for the most part, actually, most of the specimens are small-bodied animals that we're just taking out of the spoil bits there. Some of the fossils really quite nice. So talking about some of these things that we've already been working on, publishing on. This is a flat-bodied fish. Remember the group Platysommidae? So it has, you can see the eyeball here, almost like this duck beak, low slung jaw coming out there. Here's the pectoral fin, and it has this, part of it's under the rock here, but it does have this hugely kind of humped back with these very tall scales going down the length of the body. This is a fossil amphibian. This is a temnospondyl, one of these very common Permo-Triassic amphibians. This is looking at the underside of the animals. This is the skull here. This is the pectoral girdle with the big interclavicle, typical of temnospondyls. They have these really sort of flattened, massive pectoral girdles. And then this very eel-like, sinuous vertebral column going through the back. So this is a fairly small animal. This, is maybe 10 centimeters long. We also have some much larger temnospondyls in the environment, including what may be the largest of all time. Second, right below. So yeah, in the meantime, let me just say that a lot of this work would not have been possible actually without input and collaboration from the local miners. So these sites were first discovered back in the 1940s by a Brazilian geologist.
It looks like we have a question on here.
Yeah, if there's a question from
Joanne?
the Zoom.
Yes.
I can answer it now.
Yes. It's
What?
Okay.
I can't hear you.
You can't hear? I can turn it
I
loud.
can't even, hold on, I can't even now get I can't get the picture. I hate this.
Wait a
because
second, I
every
need
time
to
do
turn
this,
you up because I can't hear you.
You can't, can you hear me now?
I've turned up the speaker on the computer, so repeat what you said.
She can't hear you, Terry. Can you hear me?
Can I have the mic? Can you repeat what you just said, please?
Joanne is having trouble hearing you, and she's also having trouble now with visual. We're hearing you fine.
I had to rejoin the meeting.
Okay. Well, that's probably something on your end that I don't think we can fix, but is everyone else hearing all right? Yes. Just rejoin the meeting. Sorry about that.
No worries. Yeah, so these were sites that were originally discovered in the 1940s. And we went back to those original sites, and basically they were totally empty. We found just like little bits and pieces of fossils there. And the first whole expedition we did, we were very dejected because we were just finding tiny scraps of fossil until actually we were on our way back and just kind of on a whim stopped at a local quarry and asked some of the people there, some of the workmen, oh, have you ever seen anything that's like bone or like fish in the thing in the rock? And none of them had, except for one guy who said that, oh yeah, there was an old quarry behind my mother-in-law's place that we think had some bone back there. And it was the first time we had started working on this sort of really dark purple mudstone. And basically as soon as we got there, we started flipping over rocks and just like fossil, complete skulls of these things. So this is probably the most spectacular of the specimens that we've found so far. It's not fully prepared yet, but so this is a picture of what a close relative. This is actually an animal that's on display in Permian Monsters, Platyophosaurus. But this is the first nearly complete skull of Prionosuchus, which we think is the largest amphibian ever to have lived. So this is an animal that so it would look something like this. So this is kind of the crocodile or a gharial type temnospondyl. So the exact size of this thing is has been the subject of some debate. The largest size estimate is actually over 30 feet long. Based on the scale that we have now, we think it's probably not quite so big, but it's still in the 15 to 20 range, which is perfectly respectable, I'd say, for an amphibian. So this is probably sort of the top predator in these this paleo lake system. that we're sampling in Brazil. But as exciting and impressive as this animal is, we knew already from the work in the 40s that lots of fish and amphibians were present in these Brazilian deposits. What had never been found before were reptiles. We were really interested in land animals. Is there a question about that?
Yeah, what came away is it?
Oh, so you can see.
Repeat the question so they can hear them.
Yeah, so the question is, how could you tell that it was an amphibian? So amphibian fossils and temnospondyls in particular have a very characteristic ornamentation of the skull roof. So they have these little like wrinkly, kind of like crenulated bone surface. And some early reptiles have it as well, but amphibians also retain basically the sensory canal system, because they're aquatic, of their fish ancestors. So when you look, if you have just a chunk of temnospondyl skull, you can basically always tell what it is. You'll see that ornamentation, you'll see that sensory canals. And so, yeah, even with very little bone, you know exactly what you're dealing with. But reptiles have never been found in. So it was very exciting so the last time we were there was in 2018, and started finding reptiles. So this is, here I am very happy, having just flipped over this little rock here and found this. So this is, here are the eyeballs, this is the nose, here's the back of the skull. So this is the skull roof of the first captorhinid ever found on the continent of South America. And so this is something that we published just recently. So captorhinids are one of the classic early Permian reptile groups. If you've ever collected or really have any experience with the Texas redbeds or the Fort Sill DeLeese Brothers quarry in Oklahoma, you've probably seen this animal, Captorhinus. It is by far the most abundant terrestrial vertebrate in those deposits. At Fort Sill, at least, there are thousands and thousands and thousands of isolated Captorhinus bones you can find in the fissure fills there. So Captorhinus, it is best known for this really like notable overbite, kind of like hooked little snout with these kind of big buck teeth coming out the front, gives it somewhat comical appearance. But clearly, they were extremely successful. Yeah. Question.
Do you think that was due to sexual selection?
The question is whether this is possible sexual dimorphism, and we don't believe so because every specimen has it. It seems to actually be part of, part of the ground plan, really, of early amniotes, sort of the first reptiles, because you see it conserved in the very primitive members of all these groups. So if there's in the early ancestors of amniotes, the diadectomorphs, you see it there, you see it in these early reptiles, and then you actually also see it in the early archosaurs, the members of that eventually become the dinosaur crocodile line. So this group of Proterosuchians always has that kind of hooked snout and overbite. And it probably has to do with actually the functional constraints of the skull, how these animals are biting. They don't really have the full complement of jaw muscles that both modern mammals or modern reptiles have. So they're doing somewhat different things with their biting. But yeah, so Captorhinus, it is super common, and it would have looked something like this. So just a very reptile-like little kind of lizard creature. But there is a lot of diversity in size in the group, and some of them got quite large. So you can see here, this animal in the middle, Muratosaurus grandis, was the size of some of the biggest like iguanas today. May have been more than 6 feet long. So captorhinids are super abundant in the earliest Permian, and they actually lived throughout the Permian, being another victim of the end Permian mass extinction. So most of the captorhinids that were previously known in the early Permian are from the southwestern United States. In the late Permian, we have them from Central and Southern Africa. But they've never been found anywhere in South America until we started looking at this site. This is a site called Palmarai, what we call PB 190. This is outside of Teresina, which is the capital of Piauí State in northeastern Brazil. So this is actually one of the largest. This is kind of semi-industrial level of mining there. it's still, not, you're not using track hose or any actual like big equipment for the most part. It's just trucks. Actually, a lot of the work there is being done by, shirtless, shoeless guys just with a hammer and a piece of rebar and popping out rock in 120 degree temperatures. Incredible amount of respect for the amount of work these guys do out there. But it has exposed a huge amount of rock. So you can see here is, it's surrounded by jungle also. Like one of the problems with Brazilian paleontology historically is that so much of the country has forest cover, although that's less by the day, that there's very little exposed rock. So you can see kind of jungle around here, and then it's kind of this typical rainforest soil, and then getting into a sandstone, and then into this purple siltstone mud rock down here. And so it's in this stratum where we're finding almost all the fossils, such as this. So this is a lower jaw of Captorhinid. You can immediately tell what it is because of these very kind of peg-shaped teeth in multiple rows. So here we have 1, 2, 3, 4 tooth rows. So these Captorhinomorphs, they were very probably herbivores, and were using multiple tooth rows to grind up the vegetation. So they didn't quite have the complex chewing of like a mammal today. And they probably also didn't have like the really large gut of a lot of hind gut fermenting reptiles. But they're kind of doing the best they can. This is so early in the evolution of reptiles. There's a lot of morphological experimentation. And for the time at least, this tooth row based kind of like maceration in the skull of plant materials seems to have been worked very well for Captorhinids. So we can tell it's a Captorhinid. Actually, it's probably a member of this group, the Moradisaurians, which includes the really giant ones. And we have found a few chunks of skull of one that may have been as much as 6 feet long. So this one, you can see this is 1 centimeter here. This is quite a small one. But there's evidence for multiple species in this ecosystem. We also have the first Eclysorinid from South America. So this is a substantially more obscure group even than Captorhinids. So Eclysorinids are another early Permian group. They're actually only previously known from the lower Permian of Oklahoma. There are a few species. So there's this group that's called parareptiles, which probably isn't a real group. It's probably just a grade, which is a bunch of different sort of unrelated groups at the base of reptilia. So Eclysorinids, like Eclysorinus here is the type genus, and then Colobomictor, which is notable for having this hugely expanded premaxillary fang. So just a gigantic tooth at the front that we don't really know what it's used for, presumably hunting, but it's no gut contents or anything that have ever been found with these creatures, so we don't know exactly what they were eating. They do have this very characteristic, almost kind of like golf ball ornamentation of the skull elements, where they have all these little kind of dimples on the surface. So if you have an Eclysorinid, it's usually pretty clear what it is. But like I said, they're very rare and previously only from Oklahoma. So we were quite surprised. At this site again, to find one. And basically what happened here is, so like I mentioned, most of the fossils are being found in this purple mudstone down at the base. And one day we had been out there and we spent all day there. And we really like turned over every single one of these rocks. Like we completely exhausted the possibility for fossils. We thought, okay, it's good, we can leave. And we'll go back to the cabin we were staying at and call it a night at dinner. But what is the one certainty of kinetological fieldwork is that the truck is going to break at some point.
When it's fully loaded.
And of course, well, yeah.
It says,
And this was the case.
it says Al Clad is trying to join me. It flashed up on the screen. He may have given up.
So here, I think I can let you go ahead. Oh, you got it? Okay. Yeah, so anyway, the mud, we ran over a branch, truck's tire popped, and we were stuck. So really had nothing to do. We had like, it was kind of a too many cooks situation of everyone trying to get the tire fixed and pull the thing out. And so I figured, well, okay, I'm just gonna step back, let things, go as they will. I'm sure that they would take care of it. Sorry, I'm in trouble with the clicker. But basically, so I went back to the quarry, and like I said, we had turned over every block, so there was nothing more to do there. But I went back to that sandstone layer at the surface, like closer to the top, where we had when we first started working these localities, it looked very similar to what you get in southern Brazil and in southern Africa that has a lot of fossils in it. So we figured, oh, this might be where the fossils are. And we spent days looking for fossils in this stratum and never found a thing, like not a scrap of bone. So in all the years that we've gone back, we've basically just ignored the sandstone. And we've been like very successful finding fossils in the mudstone, so it always focused on that. But since I had nothing else to do this particular day, I went back and just like said, okay, I'll look at the sandstone. And just flipping over some of the sandstone blocks. And what should I see but this row of teeth sticking out of the surface? So clearly this is the skull of something. And then actually start seeing like bits of vertebrae, and then also skull elements with this, very unusual ornamentation that clearly is not from the time of the spotted amphibian. It doesn't have sort of the right, it doesn't have any of those sensory canals, doesn't quite look like a Captorhinopore, doesn't look like anything else I was familiar with except for this really obscure group, the Ecdysterhinians. And certainly we're not expecting to have one. Sorry, can you move that forward? Sorry, just the thing seems to be.
It's not going. Oh,
Might just have to click it.
oh,
So, okay, so and particularly this Ecdysterhinid called Delorhynchus, which it doesn't have the giant fang like Colobomictor. It doesn't quite have the kind of like golf ball type ornamentation. It's much more kind of woody and rugose. There were a lot of differences though. So in the tooth morphology and shape of the jawbones. So we found that it was, this is a very close relative of Delorhynchus, but something that we were able to name some new species, which we call Carudia fortunata. Carudia is from the Timbira word. So Timbira is one of the indigenous tribes to POE that basically means kind of like woody skin. And of course, fortunata, fortunate because of the bit of luck that the truck had broken down, forcing me to go back and spend the time finding this fossil. So I mean, those were things that were all collected in 2018 or earlier that just in the past year we finally gotten around to publishing. And there's still a lot left to come with the Brazilian work. So even without having been back in the past 4 years now, we have hundreds of specimens, including some really like beautiful new amphibian material. This is another little Tempest fondle here. A lot of work has been done preparing that big Ionosuchus skull, so we'll be very excited once that's done to have sort of the complete cranial description of Ionosuchus for the first time. And some of the like little fragments of teeth in blocks that at the time we didn't know what they were. More prep has been done, and it turns out there are more reptiles coming out of this assemblage that we're really excited about. So stay tuned for yet more on sort of the Tetradofogo fauna in the future. But shifting gears a little bit, let's hop across the ocean to South Africa, an area that historically is a lot better known in terms of its Permian fauna, but which there's still much to reveal. And talking about the work I've been doing to bookend the Beaufort group. So here is some of the exposures of the Beaufort group. So basically, the South Africa is part of a series of primarily Permo-Triassic basins scattered throughout the southern part of the continent, extending really from Kenya and Uganda in the north out to Madagascar in the east and Namibia in the west. It is by far the most extensive and fossiliferous of all of these African basins. So what's called the main Karoo Basin here covers around 2/3 of the land area of the entire country, and all of it is fossiliferous. And it has been immensely productive. There are literally tens of thousands of vertebrate fossil specimens coming out of the Karoo Basin. And because of this, it's a very rare situation where we have almost kind of like marine invertebrate levels of stratigraphic refinement, where we have actually been able to create this system of assemblage zones. So we have these characteristic vertebrate index fossils. Usually you're thinking of polyomorphs or conodonts or ammonites as index fossils. But here we actually have, in some cases, thousands of specimens of a single species. So they actually form good index fossils within the basin. And so the Karoo group as a supergroup as a whole goes from the beginning of the Permian through the early Jurassic. Within that, the Beaufort group is the most extensive, and this is the one that goes from the middle Permian through the middle Triassic. And so you can see here, these are all the layers of the Beaufort group, kind of this rainbow. So the Karoo Basin was a retroarc foreland basin. So basically it was an inland sea in Pangaea that the Gondwanades Mountains, which were at the time kind of between Africa and what's now Antarctica. It's an ancient mountain range that no longer exists, and they were eroding down. And so they were filling in this inland sea. And so what we see here is the remains. This is where the sea was. The older ones are towards the edges. Those were the ones that were filled in first, those strata. And so it gets younger as it goes towards the center. This is the last part to be filled in. And this like white stippled part in the middle, this isn't part of the Beaufort group. That's actually later volcanic intrusions. That is actually what's now the landlocked country of Lesotho in the middle, in the Drakensberg Mountains, which are Jurassic to recent. But the rest of this here is all these Permo-Triassic fossiliferous rocks. And so this is typical exposures. This is a mountain. This is called the Ufudo. They have these dolerite caps, which have preserved. They basically these Permo-Triassic rock preventing them. So dolerite is very, very dense, very hard volcanic rock. So it erodes at a much slower rate than all of these mudstones and sandstones. So it's basically kept them safe for the past 250 million years of erosion. So you get, here's, you can have hundreds of meters of exposure. A site like this, you're going through millions of years of record, just all exposed to the surface, all producing fossils. And you have this huge diversity of the therapsids, these more advanced mammal-like synapsids from later in the Permian. So all these groups like Dicynodonts, these tusk herbivores that I mentioned before, the Dinocephalians, the so-called terrible-headed ones, which includes both big herbivores and giant carnivores. Angiosaurus is the largest of them. Some of them have a skull around 3 feet long. Animal probably over 25 feet long, top predator on land of the Permian. Gorgonopsians may be better known predators than the Dinocephalians. These were also, some of them got very large, kind of polar bear size, known for their being the first saber-toothed predators in the fossil record. So have the sort of the centerpiece of like the Permian monsters is one of the Gorgonopsians. And then of course the Cynodonts, these are our ancestors, these are the most mammal-like of the therapsids, and indeed the ones that later in the Triassic evolved into mammals. They already show sort of the very enlarged dennary bone of the lower jaw and these complex multi-tusked post-canine teeth that are typical of mammals. So most of the other ones have very simple, very kind of like reptile-like teeth in some ways. So the beginning of the therapsid range, so here's a little chart showing the ranges of various synapsid groups in the Permian, where in the early Permian, you have these Pelycosaurs, Dimetrodon, and sort of its allies. And then in the middle to late Permian, you have these therapsids like Moshkops here. So it's traditionally been thought that the therapsids all basically appeared simultaneously in explosive radiation in the middle Permian. So you can see where I've marked it red here. Here's the first appearance of basically all of the major therapsid groups. So you've got Dicynodonts, Dinocephalians, Gorgonopsians, all showing up basically at the same time. They're all in this assemblage called the Eodicynodon zone. So this is the earliest and the most recently recognized of these basically these biozones that the crew index fossils delimit. So it is only exposed in the southwesternmost part of the basin. So it is by far the lowest exposed outcrop area, and is also the least fossiliferous of all these assemblages, which is unfortunate for us because we really want to understand the origins of these therapsid ecosystems. But the record is very poor, so we really have to put in a huge amount of work both to find the fossils and then just in order to interpret them. They're also, for the most part, not like super well preserved. These are actually some of the nicer ones. The characteristic Eodicynodon zone fauna. Of course, the index fossil itself, Eodicynodon. In some ways, sort of very typical Dicynodon, has the big tusk, sort of the otherwise untoothed beak. It is primitive in some ways of the palate. Actually, still does have teeth on the roof of the mouth, which are lost in later Dicynodons. You get other members. The Anomalodonts are these larger group to which Dicynodons belong. You have some very primitive ones that you don't see anywhere else, like Patronomodon here, which is notable for having this huge eyeball. Probably either the specimen isn't juvenile or it was sort of a juvenilized group, a pedomorphic group. Of course, you have these big Dinocephalians like Talpinus, and then these carnivorous Theracephalian, more dog-like predators as well. So one fossil you actually won't see here that is mentioned, though, is our Gorgonopsians, these saber-toothed predators. So it had always been said, and if you look at charts like this from 2009, it says, oh yeah, Gorgonopsians, they're present in the Eodicynodon zone. They appear at the same time with all the other therapsids. But what is that actually based on? It turned out to be extremely little. So there is one line mentioning the presence of Gorgonopsians from the Eodicynodon zone in a thesis from the 1980s. And that is kind of just has been repeated ever since then, without any description of what these specimens were, any evaluation of what they really are. So one of the things during the pandemic that I figured was, okay, well, let's finally sort this out. And instead of just citing one line from an unpublished thesis, actually get some information on these animals into the literature. So I started working in collaboration with my South African colleague, Bruce Rubich, who had been part of the team that originally collected these fossils, actually see what the deal is with these Eodicynodons on supposed Gorgonopsians. And immediately I recognized that one of them actually was not a Gorgonopsian. One of them was a fragment of jaw from these big Tapinocephalid Dinocephalians. The second one was more interesting, though. So this is the entirety of the fossil. Like I said, these are pretty poorly preserved in the Eodicynodon zone. The bone quality is not great. They tend to be quite fragmentary. But what was there was very interesting. So a few things that you'll notice is it has this very large blade-like saber-toothed type canine, and then also this very tall dentary symphysis, sort of the chin. And so those are typical of Gorgonopsians, but not exclusive to them. You see those in other early carnivorous therapsids as well. So that alone was not enough for me to say, okay, yeah, for sure, we have an Eodicynodon zone Gorgonopsian. It was the septomaxilla that really showed, yes, this is Gorgonopsian. So the septomaxilla is a bone that is inside of the nostril in early synapsids. So here you can see marked SMX there. And so basically this is related to the vomeronasal organ in reptiles. And so this is it's a primitive bone that goes back deep into vertebrate evolution, which has been absorbed or fused with the rest of the face in mammals like ourselves. We don't have the same septomaxilla. But therapsids still do, and in Gorgonopsians, it's very distinctive because it has this sort of median process that compartmentalizes the nostril into upper and lower sections, which you don't see in the other therapsid groups like Dinocephalians on the left and Theracephalians on the right. So even though this is just kind of a fragment of snout tip, on the basis of that character, we were able to say, yes, okay, Gorgonopsians are present in the Eodicynodon zone. We also looked at some other pretty fragmentary but interesting fossils from just above these strata at the boundary between the Eodicynodon zone and the subsequent Tachinocephalus assemblage zone. And we're able to say, yes, these are also Gorgonopsians. So this is the specimen in the upper left here. So we're looking at it, dorsally onto the skull roof. This is a comparison with a definite Gorgonopsian, Gorgonops, the namesake of the group, on the right marked in B there. And then these other groups, Dinocephalian in C and Theracephalian in D. And one thing that you can see is it has this bone called the preparietal, this diamond-shaped element in front of the third eye, the pineal foramen. And that's very characteristic of Gorgonopsians. Also, although the skull roof is damaged, it would have had this very broad skull roof there, which you can actually see from the edge of what is intact bone versus broken bone. Which is typical of Gorgonopsians, you can see very broad skull roof, but not in Dinocephalians or Theracephalians, where it's become quite constricted to accommodate the giant jaw muscles in these animals. So we're confident that this is a Gorgonopsian. And what's more, it has a feature that we haven't seen in any other Gorgonopsian. It has this little knob marked BOP, which stands for basioccipital protuberance, which I've seen, I think literally every Gorgonopsian skull on Earth. And this is the only one that I've ever seen that has that. So comparing it to things like Arctic Napus, a very well-known late Permian Gorgonopsian, doesn't have anything like that in the basioccipital. So even though this is a pretty bad specimen and poorly preserved and fragmentary, this on the basis of this feature, we were able to say, yes, this is a new species. This is not, previously known Gorgonopsian, so we were able to give it a name. We named it Phorkys dubei. Phorkys is one of the Greek gods who was actually the father of the Gorgons in their mythology. So it's the first known Gorgonopsian that seemed appropriate. And then dubei is named after Mr. Charlton Dubé, who is one of the comparators at the Evolutionary Studies Institute in South Africa, where this specimen is housed. Yeah.
Excuse me, I think Diane had a question of Diane, did you want to unmute and ask your question?
I'm just wondering if you're pointing to something as you're talking, because if you are, it's not visible.
Unfortunately, that's gonna be the case.
Yeah, so I am, but I am trying to do my best to give additional positional information as I talk about these things, about if it's like AV or they have the call outs. So I would just ask you to bear with me as that occurs.
Okay, thanks. I mean, it's very frustrating because it's also very hard to hear. I'm with Joanne. I can hear about 50 to 80% of what you're saying. I hear noise, but I don't necessarily hear exactly what you're saying. It's like you're talking very far away. So anyway, thank you.
Well, if I turn the mic up anymore, it's gonna feedback. I can try to put it up in the chair.
It's not so much a volume issue as it is, enunciation, but it isn't that you're not enunciating. It's that, I feel like I'm a mile away.
I'm moving the speaker closer, see if that helps. The loudspeaker, so see if that helps.
Okay, so
Is that any
is
better?
there any better?
Well, I'll see as you talk. I mean, just saying that is fine, but we'll see. Thank you.
Well, we're doing the best we can.
Yeah,
know.
so the loudspeaker's up against the computer now, so hopefully this will be at least somewhat better. But yeah, Charlton, he actually discovered one of the two specimens. So there is a second one as well, which is even worse. These are, like I said, Eodicynodon's own things are very fragmentary. It's just another part of the back of the skull. But then the rock they're in is incredibly hard. Like this is brutally hard rock, and it took him weeks with the air scribe to get even this little fragment of fossil prepared. So that was very deserving of honoring him with the name of this new species. And we were able to, try to learn a little bit about its relationships. So I put it into the, analysis of the phylogeny of Gorgonopsians that I've been working on. And it came out at the base of what I call the African clade. So it seems there's a very basal divergence between the Russian Gorgonopsians and the African ones. And that makes sense. I mean, it's found in Africa and it's the oldest one. So it sort of falls out where we expected it to. So, again, a very fragmentary fossil, but, tantalizing. It shows there's a lot of diversity in these earliest rocks of the Beaufort group that we haven't really previously appreciated. And so this is part of the talk, is bookending the Beaufort group. So let's jump ahead to the very end of it. So the earliest rocks of the Beaufort group are poorly known, and so are the latest rocks. So this is of the Sinignathus assemblage zone. This is the part that is rimming these volcanics of the Molteno group, the stippled portion in white there that are around Lesotho. And this is in the middle Triassic. So really some really spectacular exposures of the Sinignathus assemblage zone, particularly as sort of the core Sinignathus zone. You can see just like wonderful strata. This is all fossiliferous strata from near Alawal North in the Eastern Cape province of South Africa. So me standing there. But the latest portions of it, what's historically known as the Sinignathus subzone C, is very sparse and very sort of scattered to only a few hilltops in the Eastern Cape. There had been fragments of Dicynodont found in these strata. So very little bone was known from any of these subzone C strata. And they had previously been referred to this animal Angonisaurus. Uh-oh, we're losing the... Okay. Oh.
It has to turn on.
I love that we're having just as many like real world technical issues as Zoom technical issues. I think it's just really like leveling the playing field between those of us who are here and those of us who are online.
Well, the ones online that say this.
Oh, come on. Okay, it's
It's all good. We can hear you much better now. Thank you.
Oh, I'm happy to hear that. We're waiting for the projector to turn back on. If, yeah. So you can
So now we have a picture and you don't.
People here can't.
Is it really?
I have another projector.
Kristen, are you ambidextrous?
And
I am not.
That's too bad. I was gonna say, because you could always use your laser pointer on the screen there and then take your other hand and use your mouse on the board, and then we could both see at the same time. When you wanted to point to something.
Yeah,
If
I'm
you were
afraid
That's beyond my capability.
and beyond the skill of most people.
it looks like it's coming back on.
oh. These things are notoriously slow.
So in the meantime, while we're waiting for this to start up again, so the later Triassic is really well known from East African localities in Tanzania and Zambia. Okay, we're back. And for years, scientists have been trying to correlate the South African and East African assemblages to sort of get a view of biotic evolution throughout the entirety of the Triassic. But there's very little overlapping fossils, so it's been difficult. So they thought they had found one with these fragments of Dicynodont from the Sinignathus subzone C, as it was called, which had previously been referred to this animal on the right here called Angonisaurus, which is a big Dicynodont from Tanzania. But then a couple of years ago, a team from the Evolutionary Studies Institute actually found a complete skull of this subzone C dicynodont. It turns out to be a very different animal. So it's something that they asked me to describe as a dicynodont expert. It turns out to be a completely different species, which we named Ufudo Cyclops, which means basically tortoise cyclops, because it has a gigantic pineal eye on the top of the skull there. Even by dicynodont standards, it's quite large. So this actually became the basis for what we now call it the Cricodon Ufudo Cyclops assemblage zone, based on this animal. This is from the description I did a couple of years ago. And then this animal Cricodon, which is a cynodont. And particularly it's a member of this group called the Trirachidontids. So here's a skull of Trirachidon. So this is actually typical of this style of preservation of like the main chunk of the Beaufort group. The ones that I've been working on at the sort of the near and far edges, we're dealing with all this like scrappy stuff, but for the most part, it's just like gorgeous complete skulls, complete skeletons, and just, thousands of them. So Trirachidon, sort of a ferret size, little herbivore or omnivore. Here's actually a really nice specimen at the National Museum of South Africa in Bloemfontein that has, you can actually see just on the arrows there, this is 3 specimens that were curled up together in a burrow, and it consists of a complete skeleton of one, a complete skeleton of another really tiny one, the one that's marked baby, and then just the jawbone of the other one that's marked daddy. So we don't know for sure if these were the parents and the young, but clearly it's an adult juvenile social assemblage that was preserved in this den. So even though these aren't mammals yet, already we're seeing what's likely a high degree of socialization in these Triassic cynodonts. And the same is actually probably true of the ones that we're getting locally, which I'll show you in just a bit. So Trirachidontids, they're one of these common Triassic cynodont groups. But for the most part, as you can see, they're quite small animals. So like they're all kind of in the rat to cat size. Until actually this, the group that went out there. So this is the exposures of what's now the Ufudo Cyclops assemblage zone. And then in a few years ago, actually, they found a chunk of Trirachidonid that was unlike any that had been found before. So this is Dr. Jonas Schwanier, who's a curator at the Evolutionary Studies Institute, rock sawing this specimen out. And this is the chunk as they found it, with the fossil in the middle there. And once prepared, it proved to be a Trirachidonid, yes, but larger than any that had been found before. So there's the complete skull of Trirachidon at the bottom here. And then this is just the snout of this new giant Trirachidonid at the top there. So this is an animal that, when the skull was complete, we're looking at something maybe 50 centimeters long. So this is a Trirachidonid that probably would have been around the size of a black bear. So we named it Impidens. So this is a project that I did with the team there. And one of the students, Rick Tolchard at the Evolutionary Studies Institute, who had the lead in describing this. The name means like combat tooth. It's from the Zulu word impi for warfare. And then the Latin dens means tooth, in reference to sort of the large size of this animal and also the fact that it probably was a predator. So very, very rough speculative reconstruction of what the skull may have looked like of impidens here. But so Trirachidontids are members of this group called the Gomphidons, which are mostly thought to be herbivores. And you can tell that based on the teeth. So looking at a very classic one from the late Triassic of Argentina, Mesitognathus on the left, it has this characteristic Gomphidont dentition where they have these very broad molar-like teeth for grinding plant material. A close relative called Santa Cruzodon from late Triassic of Brazil, I've shown a highlight of the teeth to again show, this actually looks a lot like many herbivorous mammals you might be familiar with from the Cenozoic, where it has, low kind of lofts and basins for grinding plant material. By contrast, carnivorous cynodonts like the classic Cynognathus here, namesake of the assemblage zone, have these sectorial teeth, where the teeth are flattened, blade-like, often serrated, and with these recurved cusps. And what we see in impidens is actually a split between, if you look on the right, there's what's marked GOM on the top two figures. These are the gomphidont teeth. But then it transitions into what's marked SEC to sectorial teeth. So it actually had a combination of the two and had as many sectorial teeth as gomphidont teeth. So clearly it had these kind of flesh slicing blade-like teeth at the back, but then also these more grinding teeth at the front. So it's, with as limited material as we have, we can't figure out everything. But we suspect this animal was an omnivore. Alternatively, it may have co-opted some of its gomphidont teeth to aid in bone crushing. So sort of those malariform teeth, can also be used for other purposes. So all in all, it kind of fits with our interpretation of this as kind of a bear-like creature of the time. So may have been doing some herbivory, some predation. What's also interesting is that the specimen on the upper left is the one from South Africa. The one on the upper right is a specimen that was collected in the 1980s in Antarctica. So it seems impidens does allow us to correlate sort of the South African and the Antarctic fossil records later in the Triassic, even if we sort of nixed the South African Tanzanian correlation there. So finally, and I'll just quickly wrap up here, what else we're doing. So those were kind of the things on the back burner that I was working through. But then we're also trying to get new data out of the specimens we have. And so, some of the Permian fossils are truly spectacular. Like this is a Dicynodont skull from Russia called Gallisaurus, which is basically, the delicate skull, because it looks, this animal could have died a couple weeks ago. Like the bone quality is essentially perfect. But there's still only so much we can say based on, external views of the bone. So increasingly, as paleontologists, we're trying to look at non-destructive invasive technology to figure out what's going on inside of bones. So basically, we do the same thing that you would for a human. We put it in a CAT scanner. Medical CAT scans, like in this photo, are really only used for big specimens that we can't fit in the micro CT machines that are sort of dedicated for detailed analysis of small fossils, which is most of what we use, but these will only handle kind of a specimen up to around 15 centimeters in length. So if you want to put a dinosaur skull in a CAT scan, you need usually a veterinary scanner, or if you can get access to it, like the giant industrial scanners that they use, to figure out strength of airplane fuselages and things like that. But a lot of negotiations to get access to those, let's say. So mostly we're just looking at little things in the micro CT machine. And there's really a whole new world of information that you can pull out of these fossils. So this is a skull of one of these South African Triassic cynodonts called Gallisaurus. And it's a nice skull, as you can see. But turns out you can also get a really, really nice scan. So this is, CT scans, probably already aware, but all they are is just a bunch of X-rays stacked together to create a 3D model of what this thing is. So these are just some of those X-rays on the right there. And you want really good differentiation between the bone and the surrounding rock. Sometimes you don't get it. You don't really get a good scan out. In this case, really gorgeous. And you can see the bone is really nice, clear white. You can even see the trabeculae inside of the bones, the tooth roots and everything. All the sediment is engraved. So with a scan like this, this is work done by my student, Louisa Push, was able to reconstruct the entirety of the skull and basically confirm things that we saw on the outside, but then also see all of these features on the inside that we would never have known about otherwise, like the nervous system. So the nerves and blood vessels that went through the maxilla on the snout and may have been involved in sensing, may even have been associated with whiskers in some of these taxa. And then, of course, what's going on in the brain, and then the semicircular canals of the middle ear. So looking at that thing on the right there, that image, The brain endocast is in blue, and then the inner ear semicircular canals are in red. This is helping us to understand how these animals, like there's a lot related to both like feeding activity, how active and mobile the animals were, even the orientation they held their skull relative to the substrate. These are all things we can kind of figure out looking at the inner ear. So a lot of new information coming out on the inside of the skull. And CT also can help us out with when the specimen themselves are not that great. So this is Bolo Tridon, which is a small cynodont from the Sinignathus zone. It was thought to be sort of a relic, the only very primitive cynodont surviving to the Middle Triassic. But unfortunately, the skull is badly crushed, so we can't, and the lower jaw is preserved in occlusion, so we can't see like detailed features of the palate, for instance. But with CT, we can go in and sort of pull out everything and then digitally prepare off without damaging the specimen. Things like the lower jaw and the side of the skull. So here you can see just like the specimen on the left reconstructed, but then on the right, we basically cut the skull in half to look at all of the internal features. And really has given us a wealth of new information on Bolo Tridon. Among other things, showing us that it has a jaw morphology and dental morphology very similar to the advanced cynodonts that are typical of the late Triassic, these group called the Eucynodonts. So actually it's probably the closest relative, what we call the sister group, to this whole later cynodont assemblage that includes mammals and ourselves. So giving, only this fragmentary skull turns out to be quite important for understanding cynodont evolution. And so this is something that we're actually trying to go through basically all of cynodonts to understand the assembly of mammalian characters, including the ones that are found very close to home. So I mentioned, the last thing we can do is get back in the field. Obviously, I haven't been able to get back in the field in Brazil or South Africa, but I'm the curator of the North Carolina Museum, and we have lots of North Carolina fossils all around us. So the first year of the pandemic was still difficult. A lot of the private land that I like, industrial sites and quarries that I work on were not letting people in. The state was also not allowing state employees to really travel more than a few miles away. So still did relatively little, but then in 2021 and this year have been quite active back out in the field at a lot of these late Triassic Carnian localities, including finding some new ones. There's been, housing development has not stopped during the pandemic, that's for sure. And so much of the housing, especially in Durham County and North Wake County, is through Triassic rock. So we can just go to construction sites and find this is actually a really nice section of strata, probably the Pekin Formation. It's a little difficult with these with construction sites because you don't have the broader geological context, but it's all sort of deep river group Triassic, and have been finding more and more cynodonts. So this animal Boreogomphodon is clearly the most abundant of all of the tetrapods, all the vertebrates that are found around here. So Vin Schneider had collected several of these, and we have a bunch downstairs, and I've been finding more and more of them in my work here. So this is just beautiful specimens. Like this one on the bottom is actually one that Vince had prepared himself, and these turn out to scan incredibly well. So we're not only describing these specimens based on the external morphology, but I went up to Duke and got these CT scanned, and now my students are going through and will tell us a huge amount on basically all the details of the nervous system of the skull in general. Basically every foramen, fossa, and neurovascular canal is present in place in these things. So probably more information on the anatomy of any one cynodont than any that's ever been found. So very excited when this work comes out, probably in the next year or so. And then in addition to that, now this year we had sort of worked our way through the backlog, but now that things are opening up more again, I'm back to being summoned for new Therapsid discoveries, and already these things that have been either discovered or collected or just prepared in the past few years. These are all new genera that are now on my new to-do list that I need to get through in the next year or so. From some of these, South Africa, Zambia, Brazil, Argentina. Just last week, I was in Germany, and the week before that in Spain. Finally did international travel again, first time since the start of the pandemic, with some very exciting new Permian discoveries in both of those places, which I can't talk about yet, but we'll be happy to some point in the future. With that, thank you all so much for listening today, and huge thanks to especially my fellow museum staff around the world who have really gone above and beyond, going down to collections, taking photographs, taking measurements, creating 3D models, doing all the things that I could not do during the pandemic. So this work would not have been possible were museum studies not continuing in these circumstances. And with that, happy to take any questions.
If they're doing Zoom questions,